Hello, everyone. I'll give a moment as we have a bunch of people still joining us here, and then we'll get started in about 30 seconds more or so. All right, let's get started. First off, good morning, good evening. Thank you for joining us in Behind the Build on RAD Studio and C++ Builder 12.0. With me today, I've got David Millington. I'm Kyle Wheeler. If you haven't met me before, GM over Embarcadero. Really excited to share with you today a behind the scenes look at what our product team and developers have been working so hard at for several dev cycles. The work that you see today is representative of a lot of hands, a lot of people, and a lot of hours driving to what we think is the bright future of C++ Builder. So with that, with any behind the build look, I'll say that this comes with the caveat that this isn't perfect. This is and perfect is not our goal at this stage in the game. As you know, as developers, this is progress is the most important thing right now. I'll share our if I can go back. I'll share our safe harbor statement with you. This is just our disclaimer and our caveat that what you see today might not look exactly like it will in final product, but that's not our goal today. Our goal is to show you what we've been working on, what we're excited about, what we think the future of C++ development from Embarcadero is going to look like. And we're really excited about it. I can't say enough about the work that the team has done here in two really core areas of C++ Builder. And so with that, as we demonstrate, as David demonstrates the work that's happened, I'll just say here, please ask your questions. We've got a team behind the scenes that's available to answer any questions during the demonstration by text in the chat here. And we'll also leave some time at the end for some in-person Q&A. So get your questions ready for that. Be jotting them down if you want to stick around for an in-person Q&A, or feel free to go ahead and type them in the chat. This is, like I said, a very candid look at what we've been doing, what the team has been doing. So no questions off limits here, so please ask away. And yeah, thanks again for joining us. And with that, I'll kick it over to David. Maybe.
Hi everyone, David Millington here. I'm the product manager for C++ Builder here at Embarcadero. This is a very exciting webinar because today we'll look at a preview of what's going on internally, behind the scenes, of two new features for C++ Builder. First, the new upgraded Clang toolchain, which is more than an upgraded compiler, but a new runtime library, STL, debugger, linker, and more, and is giving very exciting results for C++ quality in our automated tests. The second is Visual Assist integration, which supplies code completion, navigation, and more within the IDE. It's important to discuss why we're making these advances. Ultimately, our product, C++ Builder and RAD Studio, is about helping you get things done. Writing code that works, is reliable, and helping you do so productively. For the C++ toolchain, we aim to have a modern compiler supporting modern C++ standards that optimizes well, resulting in performant code, has good debugging tools, and matches platform standards. You need to be able to run C++ code you find online, use third-party libraries, use modern safe coding standards, and write code you expect to work and have it work. For productivity, we aim to have fast code completion, which is one of the most important tools in an IDE, and additional tools that help you understand your code structure, navigate around your code, and refactor and edit your code. All these are highly useful for assisting your productive development. Those two lead to the upgraded C++ toolchain, a modern compatible C++ toolchain with great C++ standards compatibility and of course our own extensions, and the introduction of Visual Assist, which is a code productivity tool that up until now has been only for Visual Studio, but is now moving into C++ Builder as well. Let's dig into the new Clang toolchain. Our new toolchain is based on Clang 15. It uses the COF object file format and produces PDB format debugging info. Now on Windows, our old toolchain used Unix or Linux style object and debug info formats in the past. So these two changes to the object and debug info formats mean that it is usable or easily compatible with many other common tools. There's a lot of tooling around PDB, for example. Both COF and PDB are the norm, i.e. the platform standard, on Windows. We no longer use the old iLink linker. Instead, we use LLVM's LD linker. We hope that this linker will be great at linking large applications and libraries and also faster. For the C runtime, we use the Universal C runtime, a Windows component. For the C++ runtime, which is our most in-development space at the moment, we use a mix of technologies from LLVM, MinGW, and elsewhere. All are open source with compatible licenses. For the STL, we use LLVM's libc++. Let's fire it up and have a look. Now, we said this is a behind-the-scenes and unfiltered webinar. Well, the new toolchain is very promising but still incomplete. So we'll show you command line building with C++, using Delphi extensions, debugging using PDB within the IDE, performance and standards compatibility, and then we'll cover what's not finished yet. Let's make our first app with the new toolchain. We'll invoke the compiler directly, since we don't yet have MS-Build or CMake support and the compiler is not yet in the IDE. I'm going to use two units, a main one and a second unit which just returns a string. Fairly basic stuff, just printing hello world. Now when I compile that, I get an output.exe, and when I run it, I get a message. This gets more interesting once I start debugging. Let's re-invoke the compiler, but this time tell it to generate debug info with the --debug flag. If I run a directory listing, you can see I have both an exe and a PDB file. Now PDB is the most common debug format on Windows, and we hope using it will let you do many advanced things. Now the compiler is not yet integrated into the IDE, that's why we're compiling on the command line, but the debugger is. If I go into our in-development IDE and use run load process, you can see I'm selecting the debugger to use, and I've placed a breakpoint here too. And when I run, we should break at the breakpoint. This is loading PDB format info and is using LLDB15. And as you can see, I can evaluate the string. So this is a basic demo, but it shows PDB format inside the RAD Studio IDE. In our webinar promotions, we promised you a webinar that was unfiltered. Well, let me fulfill that and show you some of what's not working. When evaluating complex types like a string, map, or other collections or data structures, when the debugger shows you the string contents, it's kind of lying. A C++ string is actually a complex data structure, but you want that to be hidden. You just want to see the string contents. And that's done through a formatter, which is code that tells the debugger how to interpret the data types in a user-friendly way. Now, we haven't finished our formatters yet for the new STL that we're using, and the string formatter that we saw just now only works for long strings. So if I try to evaluate a short string, let me edit the code to have a short string and recompile. Now you may not know this, but C++ strings have optimizations for short strings, and supporting that needs to be built into the formatter. So this is a good way to show that they're not done yet. When I run and debug this time, you can see the debugger isn't interpreting the string correctly and is instead showing us the entire string data structure. So, definitely work to do here, and showing you what's underway and incomplete is part of this webinar. But it's pretty amazing that we have a COF compiler emitting PDB and a debugger inside RAD Studio loading and supporting that. This is using the platform standard, and the PDB debug info format especially is something we've had many requests from you to support. Here it is. Now, performance. I have some test apps. First up are some tests for general performance. StdMap, which roughly tests memory allocation, traversal in memory because a map is implemented with a tree, and STL quality. And std unordered map, which tests code gen and again STL implementation quality. Here's the code. It's quite simple. I have 2 million shuffled random order ints, and it uses std chrono steady clock to time performance for adding those, then for finding each one of those 2 million ints, and then for deleting those 2 million ints, again in their shuffled random order. Random values are important in order to mimic real data. So let me compile and run it using high optimization. And we need to run the old one too. This is built with our old Win64 compiler. The new one is noticeably faster, especially for unordered map. Now these are just numbers in a console. Let's not keep running apps and comparing numbers in text, though I wanted to show that we're building these with the new compiler. But let's look at this visually. Looking at this in terms of visuals, we see that using the new stdmap in our new STL, which roughly tests memory allocation, traversal in memory, and STL quality, the new toolchain is between 6 to 14% faster than the old Win64 toolchain. And looking at unordered map, which tests hashing, code performance, and STL quality, again, we see some massive improvements over the old toolchain, up to 70% faster. Now this is a combination of code gen and the quality of the new STL. And for those of you who've run into issues with our old STL, this should be really encouraging. On to floating point math, and I wrote a similar benchmark, first just summing several million numbers, and then doing some more complex math functions with them. Now, for simple summing, addition of numbers, we would expect to see very similar results here, and we do, although oddly enough, the new toolchain is 3% slower. That may just be within the bounds of test error. But the really interesting case comes when comparing some complex operations like trigonometry functions and square roots. And here I want to compare just the old and new Win64 toolchains. So let me run this one, compiled with the new compiler. It completes a few million operations quite quickly. Now let me run the same code built with the old toolchain. Once we get to the trig functions, it just keeps going. I'm waiting and waiting, and I'm going to edit the video. Now, I edited to skip ahead because I didn't want to keep waiting. It took that long. Let's look at the results. The new toolchain is 10 times faster. Wow. Now, there are reasons for that, and they are mostly related to the new C-level RTL we're using and the various implementations of the complex math functions. Now, we should note that performance is not our goal in the initial release. We want it working to high quality and then work on performance. But we can see with these fairly basic tests that comparing the old and new toolchains, you'll get either on par, which is fine, ranging through to some significant improvements. Okay, what about STL quality? Now, looking at stdmap and std unordered map gave a bit of a hint about STL quality. And quality is a key aim with the approach we're taking for this work. That's why it's taking a while. We're trying to do it right, and is a major driver behind the decisions we've made. So I'd like to test a fairly complex STL type, std variant. Now this is a type we have a lot of reports about in our public bug tracker quality portal. And if I try to compile this with the old toolchain, well, it's a little embarrassing, but it doesn't even compile. So let's compile this on the command line with the new toolchain. And there we are. We can run it, and yes, those are the correct results too. Let's move on from the high-quality STL to something more C++ builder-ish, one of our extensions. A key language extension is property, which is used heavily for Delphi interop and working with components. Now in this build, we are not linking against the Delphi runtime, but I can still add a property to a plain C++ class. This class implements a VCL-like list backed by a C++ vector. The key here is that this class has two properties. First, count, which is a simple property that returns the number of items in the list. And second, an index property, which is a much more complex kind of property, and that lets you read or write to one of the list items. Then back in the main code, the list has a few items set, and it's then iterated. So let's compile and run this. And you can see the compiler is happily accepting the extended C++ builder property syntax and is functioning correctly. So this looks really promising. We've seen a new Clang, the coff and PDB debug info, debugging in the IDE, some tests of STL quality and C++ builder language extensions. And there's a lot I haven't shown you. We obviously support much more than just property. For example, this preview is skimming the surface. But this is a behind-the-scenes webinar, and as you can tell just from the fact I'm compiling on the command line, not the IDE, there are still things to be done. For example, we don't link against the Delphi runtime yet, and that means we don't yet have a VCL or FMX app. And getting what we call a one-button app, VCL form with a button on it, is a major milestone. It's underway, but we're not there yet. Exception handling, especially mixing in Delphi exceptions, is underway, and we're working on a different approach to SEH. Compiling from the IDE, as I mentioned, we can debug from inside the IDE, but we still need to add the compiler. Dynamic linking. Now, we're currently working on making the compiler pass all tests with static linking before moving on to dynamic. And then a variety of details, things like compiler identification so CMake knows what to invoke, or the exact folder structure of our headers and other files and so forth. Those are small details but important, they're further out. Now, I mention all these because the premise of this webinar is not to wow you on something that is coming out tomorrow. It's not going to be ready tomorrow. It's to share what we're working on and the direction we're going. We think is very promising, but it's important to be open that there's a lot of work left to do. However, we do have this in our beta. Now, we're not promising a particular release version, but our C++ Builder beta program is open right now for those who have maintenance and update subscription, and you can try this compiler out today if you're eligible. And we'll continue to have new betas as we add more functionality. In fact, our current beta customers have been asked to test its compatibility and functionality across general C++ source, how compatible and functional this is with random useful C++ libraries, where, as you saw, we're hoping the STL quality and C++ standards we have will give excellent results. So that's a preview of the new Clang toolchain. You saw a toolchain that is currently command line only, and we focused on the C++ part, although we saw some of the Delphi extensions. We saw some C++ test results showing the new STL implementation and things that work great in the new toolchain, and some performance tests. I also really want to emphasize the approach we've taken of making decisions based on quality, on taking the time required, and the decisions we've made about the technology foundations we're embracing, things like LLVM, libc++, and the LLVM linker, the new C and C++ RTL, things like that. We build on these to add the C++ builder benefits, and these are the right decisions and promise really good results. Now, it's obviously not finished yet, and that's the point of this webinar, to show you a behind-the-scenes look. But the key takeaway is how exciting this is. It's modern in every sense. It's robust and reliable and performant. It uses the platform standards. It's highly compatible. We have lots of passing tests. It's high quality. We have a new linker, a new STL, and more, all while bringing you our C++ builder extras and the language extensions required for the benefits of VCL and FireMonkey apps. And on a personal level, the parts I most love myself are the PDB debug format, the new STL, and the new linker. And you can start testing it today if you have active maintenance or update subscription and join the beta. Let's move on to part 2, Visual Assist. Visual Assist is a productivity add-on for Visual Studio. It provides navigation, refactoring, and many other features, and we've been working on integrating it into C++ Builder, with a focus on the most key productivity needs that you, our C++ customers, have today. There's code completion, and this is one I expect may be exciting for many people. Searching, your advanced code and symbol search. Navigation, more ways to jump around your code in useful ways, and even maybe some refactorings. Now the first version aims for the most key features we can add, and we plan to keep on adding more Visual Assist features as we continue over the next few releases. And if you have update subscription, you'll of course get those as we add each release. Just like Clang, what you'll see here today is heavily in development, and it's not complete. And we may or may not ship everything you see today. The user interface is not finished. It is clearly an in-development product. But that said, let me take you on a tour of the first version. I'm going to show you code completion, find references and find simple, two really useful code search tools. Something we've added just for C++ Builder, which is toggling between the implementation and declaration of a method. Go to implementation, which is a really neat way to either go where something is implemented or go to an ancestor implementation too when you have multiple virtual method overrides. The VA outline window and rename refactoring. And because it's behind the scenes, this openly mentions quirks and issues we're still working on. Let's start with the Visual Assist menu. In the internal build of C++ Builder that I'm using, all Visual Assist functionality lives here in the VA menu. But I want to assure you that this is one of the things that marks this as a preview. The final version will not have this menu at all. Instead, the functionality will be spread over multiple menus like Search and Refactor, as well as the Editor context menu. But this is behind the build, a preview webinar, and so you get to see our in-development menu locations. Let's look at code completion. I have a C++ project here, and I'm going to invoke code completion inside this method. You can see it pops up straight away, very fast. This list shows the name, and the full information about what's selected shows up in a pop-up window to the right. So it's fast, lots of items. You can see all the expected T-form items like action, activate, active control, and so forth. So what's not quite right yet? Well, you might have noticed that I typed this arrow, and that's because currently we're getting different results, not wrong results, just different, if we complete on an empty line. Now let's try it. What we have with this arrow includes the methods, properties, and fields from ancestors of the form. But on a blank line, it shows the local scope only, what's introduced in T-form 2. You can see button, new click, cell size, and so forth, which if I flip over to the header, you can see are actually introduced in the form, in the scope of the class within which we're completing. So right now, depending on how we invoke code completion, we're getting either items introduced in local scope or everything. Now we plan to merge these so that completing on a blank line includes both items from the current scope and ancestor scopes as expected. The takeaway is that we have a completely new code completion implementation and also the speed of the results. Now let's look at the various search or find functions. The first is find references. This is a really useful feature to find everywhere a particular method or type or whatever is used, that is, all the places it's referred to from. And it's a great test to see if a tool like Visual Assist understands a codebase. If find references works, other things are likely to work too. So let me find references to the cell painting type. This is an enum, and the question I'm answering is, where is cell painting used or referred to throughout the project? And here it returns a list of everywhere it's used. You can see where it's defined, methods that take a parameter of that type, and the places it's used. It shows everywhere that cell painting is referred to, thus the name find references. Let's try in a method, say calc distance. You can see find references finds everywhere the calc distance method is both defined and used. And this includes, by the way, inherited and virtual overrides if you have them. A find references can search within the current unit within this menu item, or the normal way to invoke it can search the current project or the entire project group. And finding references is a fundamental productivity tool, and it's looking great. Next up is find symbol. Now, find references found everywhere a specific symbol was referred to was used. Find symbol has a database of every symbol that is defined, not only in your project or project group, but the headers that are used as well. That is, you use find references to find where something is used, but you use find symbol to see what exists, and of course to go to where it's defined. You can see in this project, I have 160,000 known symbols. Now, most of those will come from the C++ standard library and from the Windows headers. If I type handle, for example, this will take me to where the handle type, one of the fundamental Windows types, is defined. But if I type something else like set window, you can see all the symbols that contain the string set window being shown. Now note how fast it is to search, over 100,000 symbols and updates on every keystroke. This has features to exclude search terms and to make sure the search starts with or ends with a phrase. You can also constrain the search to the current project group. Now if I search for grid, I get quite a lot. But then constrained to only in the current project group, you can see how it now shows only the symbols containing grid locally. And you can even filter even further to only classes, structs, and namespaces. And when I turn that one on, I get the grid type only. So find symbol is very powerful symbol search, fast and flexible for how and what you want to search for. Let's look at something else, the VA outline view. This is quite similar to the structure view and shows Visual Assist's understanding of the current unit. We're not sure if we'll ship this, since our existing structure view does the job quite well, but it's also a powerful alternate outline. It's been useful for us in development because it's a quick way to see how Visual Assist understands the local code. And we'll be looking for feedback from our beta testers if we should include it. So we have both our existing structure pane and the new VA outline pane, or just our existing structure pane. I want to note, though, that this is a great example of our integration in that it's a dockable window, i.e. it's fully part of the IDE. Now let's have a look at some navigations. The first is Go to Implementation. This is a really neat navigation tool that takes you to a method. I'll try this on Recreate Grid. You can see it pops up a small menu, which is keyboard navigable, that shows both locations for the Recreate Grid method, where it's declared and where it's implemented. And if I go to the header, you can see it takes me there. But equally, and this is a preview behind the scenes webinar, you can see the menu has some glitches and characters that can't be rendered. We'll fix that. Now, if there's no ambiguity or multiple choices, then rather than showing a menu, Go to Implementation takes you straight there. Let's try on T component. You can see it just takes us straight there. So this works for methods, types, everything. I also really like that it will show a menu. It lists everything you could be trying to go to and you just choose one. Really useful. You can navigate that menu with a keyboard. You don't have to use the mouse for any of this. And of course, it's very fast. The next one is something that we've added especially for C++ Builder. Now, in Delphi, you can toggle between the interface and implementation for a method with a keyboard shortcut, Control-Shift up or down. And implementing this for C++ is one of our top feature requests. So that's what we've done. This method, Go to Declaration or Definition, implements that. Now let me choose a method in this form like PaintGrid. I can use this to toggle between the declaration and the definition. You can see it takes me to where PaintGrid is in the header, and then if I click it again, I'm back to PaintGrid in the CPP file. And this, of course, will have a keyboard shortcut, so it's a very fast and efficient way to navigate between the declaration and definition of the method that you're currently working in. Between these and the various find references and find symbol features, there's a lot of power here for quickly finding and navigating to key areas in code. Now let's look at the final feature, rename refactoring. Refactorings are a really powerful productivity feature that automate tedious or complex operations. Renaming is a fairly fundamental one that most people do via search and replace, which is not reliable, since it can rename some things that are not applicable or miss things that are, plus it's slow and tedious. And what you want is a rename refactor method that knows the usage of a symbol, and that's where Visual Assist comes in because it has a fundamental understanding of your code. Now, this app has a very major class that is used everywhere, and that's the grid class. So if I want to do the most dangerous thing in a demo, the thing with the biggest impact for this app, it would be changing this. So let's do that. Let's rename it. Note as well that I have a comment referring to grid 2, and we can normally expect that if I rename the type, the comment will get out of date, which is not good for code maintenance. So I'll put my cursor in the grid symbol and click rename. I'm going to rename my grid Fuzzle. Note that it lists all usages here. The items that we'll rename are checked, and some are unchecked, such as grid.h, because it makes sense not to rename that. That's a different operation. I can also turn on searching in comments and strings. Now, when I scroll to the top, I can see my reference to grid in the comments, so I'll check that. I want to rename it. And when I click rename, you can see it has renamed in multiple files. You can also see it's even edited my comments so that it's still accurate. That's pretty amazing, and most other refactoring tools won't do that. Now the real test is, will my app compile? Let's build. And yes, it does. And when I run it, you can see the app functions perfectly. Now that renamed across the project. It can also do it across a project group, even renaming inside a comment. And of course, the rename refactor is not just a simple search and replace. It's highly aware of the code and code structure. In the same way that find references is aware of where and how symbols are used, rename refactoring is ensuring that it renames the actual parts of code that you really want to rename. That's one of the powerful parts of Visual Assist. So that's our in-development version of Visual Assist, delivering the first key features. Now in our current build, you can see some things are missing. You might have noticed that LSP was still present and passing, and there was no status instead showing how much of the project Visual Assist had passed. We covered that the menus are not in the right locations and are all clustered together. There were also things I didn't show, such that it is not yet aware of the full set of system headers in which are being used, so it can confuse currently VCL and FMX symbols with the same name, like application or T-button. But work to fix that is planned. Also, you might be asking, if we have code completion, will we have parameter completion? We hope so, but that's still uncertain for the initial release. However, we saw code completion, which is incredibly fast to display. Find symbol, a really useful feature, and a couple of different versions of find references, which is one of the core features that demonstrates a tool like Visual Assist works and understands the code. We saw going between the declaration and implementation of a method, which is something new for CBuilder. We saw going to implementation, which is really neat because it handles all the places you might want to navigate to. And we saw the VI outline window, and finally rename refactoring, which even renamed in comments. So following the behind the build theme and showing you an unfiltered look, I've shown you an in-development version, including its bugs. But look at what's possible. We're searching, we're navigating, renaming, code completing. This is really exciting stuff. So I want to return to a slide I showed you at the beginning. This shows the direction we're going in and why, and what both the Clang upgrade and Visual Assist will give you. Now it's really important to communicate that these are not finished. In a sense, that's part of the purpose of the webinar. We promised you an unfiltered behind-the-scenes look. Both these features are not yet done, and there's still a lot of work to do. But equally, this is the direction we're going, and what we have working is really promising and really exciting. I want to share something personal here, which is that areas like code completion are things I've wanted as very much to improve, and equally I've wanted to add more productivity tooling and have a new compiler, STL, and new linker, and so forth. And because I work internally, I'm able to use the things that I showed you today. I'm using the new compiler toolchain and everything that comes with it, and I'm using Visual Assist, both of which go beyond just making things better, but introduce new, useful, amazing functionality and quality. And when I use CBuilder today, I'm really enjoying it. It's a pleasure to use, and I'm loving what CBuilder is with these two. And I just can't wait until we get it into your hands as well. So thank you for watching and for being C++ Builder customers. We hope you love what you've seen and you're as excited by it as we are. Let's move on to the Q&A.
Thank you, David. And thanks for the attention in spite of the technical difficulties that some were having. Just a note to all, we have recorded this and we will be sending it out. We may also do a revisit to this webinar in the next week or so, depending on the demand for that. Quite a few questions here. David, would you like to call out any specifically and address?
There are an awful lot of questions. So thank you everyone for all of the feedback. Look, I'm still scanning through them. I managed to answer quite a few during the webinar itself, but Carl, I recommend we just start at the top and go through, I think.
And I will say just some general ones that came up here. We've obviously pointed to the beta as being, that's active, something we're working on right now with our general customers of C++, C++ Builder and RAD Studio. It is available to premium support customers, and I believe should be coming shortly for the rest of the RAD Studio customer group. It does require an active subscription contract with us or a support contract, support and maintenance, in order to take advantage of that and to take advantage of RAD Studio 12 upon release. And then just a generic kind of follow-up to some questions here. This is obviously foundational work. This is, some will say this is a long time coming, but this has been a big undertaking for us and the team. But we expect that this will shorten development cycles in the future, as far as adding features for other platform support, changes to the IDE itself. Those will come much easier now that we've begun this and are in the process of doing this foundational work. So we're really excited about what the future holds here, and believe this release really sets us up for the future.
And I hope it's clear as well how excited we are by this. It's quite rare for us to share something that's in development, but what we saw was really cool stuff. I think it was really great to be able to show what's working.
All right, I'll just talk through some of these that I see here. David, feel free to chime in. What is the future for mobile development in C++ Builder? As I said, this is foundational work that we're undertaking right now, and we believe that future is much more attainable in the future, as we will more easily be able to address changes needed in the IDE, and obviously moving to a standard like this, like Clang, allows us to have some opportunities there for easier development. So we have high hopes and great expectations for the future in that regard.
There were a sort of set of questions about LSP running at the same time as Visual Assist, which perhaps I can answer because there were multiple of them. So the questions were along the lines of, could see the old C-Query LSP running in the background while demoing Visual Assist, or how do we disable LSP or something like that. And yeah, that's how it is in the current build. And of course, this is an in development one. What's coming is the option to toggle, so we have either Visual Assist or LSP, and when you turn Visual Assist on for code completion, LSP won't run for code completion. Or if you turn LSP on for code completion, Visual Assist will still be there for fine references and stuff, but it in turn will hand over code completion and stuff to LSP. So you'll be able to toggle between the two, and if you want to run only Visual Assist, then that's the plan, that you'll be able to do that.
Questions on what's coming with Visual Assist. So this was our first real attempt at putting something into the IDE. We expect that this will, obviously, if you've been a Visual Assist user on Visual Studio, you've seen that there's quite a few features. And with, I don't know how Chris is on the call, our architect here for Visual Assist. I don't know how many features we could list out that are in Visual Assist because of the long legacy of just improving on Visual Studio that we have. But this was a first attempt, and we wanted to get some of the most used features in. we expect that work to only continue and improve as we develop in the future. So if there's something that specifically in Visual Assist that you've seen that you really like, feel free to ping us, put it into the support forums, and we will prioritize that accordingly.
So Carl, I can see a few other questions around Clang. I mean, a few comments here about how it looks really exciting, which is great. There's some questions about the linker, especially around the linker speed. A couple of questions there, and yes, the new linker should be a lot better in many ways. Speed is definitely one of them, but also, you know, sometimes if people have really large projects, it can really stress a linker. And the new linker should handle, you know, large project sizes better as well. And plus, one of the other things is about moving to the, you know, changing some of the underlying technology, like our object file format or debug file format. You might not always necessarily pay attention to those because, after all, you know, you write code and you get your resulting executable and you get debugging in the IDE and so forth. But the technology that we use there really does enable some fantastic stuff in future. For example, there are multiple linkers that work with the object file formats, you know, and debug info format that we're using on Windows. So it would be entirely plausible to, you know, even on your own project, use something else. You know, where that kind of thing would currently be quite difficult. So yeah, the new linker should be a lot better in speed, and especially when you have you know, gigantic projects that you throw at it. There's a big benefit to come from you know, the technology that we're using in terms of what we feed to the linker as well. There are also some questions about the STL. So what tests are passing for the STL? This was in relation to the demo of std variant. Questions, will other things like std optional work, and you know, a couple of other things like that? And the answer is definitely yes. So we have a different STL here, which you know, contains implementations for things like variant that we showed. I demoed that one because it's one that I know that, you know, is important to many people, and it's really great to be able to demonstrate how you know, smoothly and correctly that works with a new toolchain. The STL is actually closely tied to the C++ RTL as well, and that's quite hard to demo the underlying runtime library, but it's an area that we've been doing a lot of work, and yeah, that's looking really solid as well. And you know, the tests that we run for the old and new toolchains are not 100% the same. Like they overlap but aren't exactly the same. So I can't sort of tell you a number that's comparable. But we are seeing really good, you know, excellent quality in the new toolchain. You know, even in an early version a couple of months ago, for example, we were seeing results that you know, were excellent, and you know, looked really solid compared to the old BCC 64. I'm not sure if we've lost Kyle, because Kyle, I can neither see you nor hear you.
I'm here.
I will continue to go through some of the questions. Oh, great. Sorry about that.
No, so some of the questions, as you all probably know, I'm not super technical. I'm only technical enough to just be here and point to David to answer the questions. So as the questions get more technical and more in the details on what's coming in the future, I'll defer those to David. And again, just the caveat here is that this is a behind the scenes look. So you know, as candid as we can be, we really don't know what and when some of these future development items are going to look like. We know that this is the necessary change and necessary improvement that's needed to set us up for success in whatever directions that we go. I would say at this point, I mean, there's questions here around, you know, 64-bit compatibility, other target platforms. All of those things are on the table now as we've done this groundwork, and so we expect to have more movement in those directions as we move along. But again, we don't know what we don't know, and we're focused heavily on improving the toolchain with Clang, and as that is stabilized and more finalized and released, then we can begin having those conversations around what's next. So as far as what's next, you know, again, we have some historical posts and things that people have asked for, but as other platforms emerge and become, you know, more prevalent in your development, let us know what you're after, and we'll prioritize accordingly. All right. Anything else you want to highlight here, David? I know we're
I can see a few questions about Visual Assist actually. So there's a question about whether find references works across a project group. Yes, it does. Look, I just demoed it with a single project. But yeah, Visual Assist is definitely aware of when you have project groups and you have multiple projects. And yeah, you can find references, you know, across different projects, you know, within the one project group. The same for things like renaming. There was a question as well about LSP and whether, like, it noted that cQuery you know, breaks, especially with your code. You start typing code and then it gets to a point it won't compile anymore because you're busy writing it. And will Visual Assist work more often? And yeah, that's going to be a massive improvement. Like, Visual Assist is so exciting within the IDE. It really is. And first of all, Visual Assist will definitely work more often in general. But also Visual Assist technology is something that is, you know, positions it to work better in that kind of situation. Its parser is able to handle things like code that you're in the middle of typing, you know, much better than something like cQuery. So yeah, Visual Assist will be a huge improvement. It's you know, as I said at the end, it's a real pleasure using both the new Clang and Visual Assist within the IDE. You know, so really waiting to get that out. Let's see. I think there were hundreds and hundreds of questions coming in, and apologize, it's quite difficult to sort of run through them all. So there are lots saying, you know, sounds great, want it now, and you know, looks awesome. So thank you very much for that. That's pretty much what we hope you react. You know, we believe this is exciting foundation for us, and it's really great seeing these comments come in that echo that. You know, there are a few questions about you know, with code completion, will we do additional work with Visual Assist? I mean, likely, because Visual Assist is very powerful and can do many things. I think just drop us a note about what you'd like to see. Yeah, there's yeah, a lot of power and a lot of potential in there.
There's one question here, David. I think we talked about this internally around. Let's see, we have some 32-bit applications that we need to upgrade to 64-bit still. Do these features also work when compiling for 32-bit? So maybe we can go into that a little bit and some of our decision-making process there.
Cool. So all of the Visual Assist features definitely work whether you're compiling for 32 or 64-bit. Those are IDE level features. If you have C++ code, it'll handle them, you know, no matter what you're targeting. So yeah, that will work no matter what. In terms of the new compiler, of course, right now we're targeting Windows 64-bit, and that will be in our initial release. And a few reasons for that. One of them is that we see a lot of interest in moving towards 64-bit. In fact, that question was asking about moving to 64-bit as well, I believe, from 32-bit. And of course, 64-bit is the future and what's the norm now. So in terms of moving to Clang, we see many more people interested in 64-bit than 32-bit. So that's one of the reasons why we've chosen 64-bit as the initial one. But of course, we want to roll this out to Windows 32-bit as well, and that'll come once we get out for Win64 first, and then roll it out.
Will Delphi users get jealous? I like the question. Yeah, I'm not sure if they'll get jealous. Obviously, we want to have a solid product of RAD Studio, regardless of what language you're using. And so I think that this is yes, this is a little bit of catch up for C++ Builder, so potentially. But my goal, and I think David's goal as well, is to bring all languages that are supported by RAD Studio on parallel in terms of on parity as far as what they can do, and then put our focus on the IDE itself into things that benefit everyone. So we are in a little bit of competition with the Delphi side, but our goal is to create an ecosystem that works for everyone regardless of their language. And on that note, I'll just mention that we are as we're doing this foundational work, there are other things that we want to bring to our RAD Studio customer base in terms of other languages supported. So we are currently looking at, I know we've done some marketing and around and some community efforts around Python development. That's something that there seems to be quite a bit of overlap with, but also some benefits that are gained from using RAD Studio. And so we are currently evaluating adding Python support into the IDE at some point in the future. Obviously, our focus is on our existing customers and what they need most, and a lot of that comes in terms of stability and improvements on platforms that are supported there. So we don't want to take anything away from the development efforts that we've done here, but we are looking at broadening in our scope and what we can offer. And again, the more people are using our IDE, the more we can put focus on major improvements in the IDE itself. So it's an exciting future and something that I'm pushing for behind the scenes, and I know David is as well. So but we do have some work to do on all fronts, as you've seen. This is again a candid look at development isn't something that we snap your fingers on, and so we acknowledge that, and thank you for being patient with us. But we do hope that this represents a move forward for us, and you'll join us in that move.
There were a couple of questions, Kyle, about the integration of Visual Assist. And I think they're asking sort of how integrated will it be. For example, there are two about whether you have to save your files before you can use Visual Assist, and another one about dockable windows. And I think the answer to those is that it's fully integrated, as you would expect. So if you modify a file in the IDE and you don't save it, it's modified only in the IDE, Visual Assist is aware of that. And in fact, in the demo I showed when I did a rename refactoring across a few files, that modified those files in the IDE. It didn't modify them on disk. It was an in IDE modification that you could then choose to save, or you might not save. Fully in the IDE, exactly as you'd expect. And the same goes for things like the dockable windows. If you have the VA outline view, for example, and it's docked, and you save that in your desktop, then next time you close and reopen the same desktop, the window will be back there. So our goal is full native integration.
I think we covered this. VA code completion works for both classic and Clang compilers, correct, David?
It should do. I mean, there's no reason why it wouldn't, unless we make a technical decision to keep the current code completion for classic, because classic and Clang currently have two different completion managers. But no, what we want to do is just be able to toggle to Visual Assist or not. So yeah, that's the goal. This kind of question is kind of the sort of detail that we can't quite answer because we haven't got to the release yet.
Right.
So I don't want to promise it. It will definitely be working with Clang. Clang is where people are these days, but hopefully it'll work with Classic as well.
Is there a deadline to Classic compiler? I'm assuming that's like an end of life type question. As far as I know, David, correct me if I'm wrong here, but we're allowing users initially to choose whichever compiler they want to use, correct?
That's right. So yeah, currently you can use the Win32 Classic or the Win32 Clang compiler. We have no deadline on when we will phase the Classic one out. So yeah, nothing at all to share there. So let's see. Yeah, a couple of questions about Clang, sort of about explaining the work that's been done so far, and what's involved in what we're doing. Look, yeah, it's really complex stuff actually under the hood, and that's one of the things about demoing is it can be a little hard to demo a preview version because at some point it sort of all comes together and you suddenly build a VCL app and it looks easy, but there's a lot of things in there. But yeah, the work so far has covered a whole bunch of stuff. All our Delphi extensions, for example, I showed property. But let's take things like, okay, you have a C++ type, and you want Delphi style runtime type information to be able to be generated, for example. All sorts of things like that are under the hood that are really tied to the integration between the two languages. And of course, we've been moving our entire runtime library and STL and the C runtime library and the object file formats and the debug formats, and all of these is major changes and major work. So there's been a huge amount of work that's been done so far. And I think one of the reasons we're showing the preview now is because we're on the edge of it being finished. It's obviously not finished yet, but the end is in sight. And it's really great to be able to share where it is right now, because after having done so much, as we said, we're fairly open. There's stuff still to do, but it's it's on the path to completion, which is really great.
All right, we're coming to the end of the time here. I just want to say thank you, and thank you for the feedback around our transparency here. I know it's not easy for some like David to share kind of what's ongoing and what's in process. We generally wait until we have it all bundled up and it's nice and pretty, but I really wanted to share what the team has been working on, show the community and you all what we're doing behind the scenes and what you can expect from us in the future. So I know this isn't a look at everything, and I know it's not feature complete, but I feel like transparency in times like this is important, and so we wanted to share that with you. So thank you for your patience, and yeah, again, if you have any questions, feel free to send any further questions, anything we didn't cover. David Millington at Embarcadero.com, Kyle.Wheeler@Embarcadero.com. We're happy to assist. And at least connect you with the right people internally. And again, using our forums, feel free to post any questions there or any requests. And again, this is foundational work. We expect a bright future, and hope you'll join us in that journey. So thank you all.
And thank you from me as well. It's been really exciting and really great to present what we're doing, and really appreciate all the feedback that we've got. People are really excited, and so are we. So thanks for watching.